welcome to our video on independent events. Before we talk about independent events, I need to define two terms. I want to talk about mutually exclusive events, and also then I'll go on to talk about independent events. The reason I'm defining these two terms in this section is that people often get these two mixed up. So I want you to really make sure that you are not mixing them up and that you're clear about the differences between the two. Mutually exclusive events are events that cannot both occur at the same time. So, for example, if you flip a coin, you've got two outcomes. You could get a head or a tail, and they are mutually exclusive because you can't get a head and a tail at the exact same time with one coin flip. You can only get a head or a tail. With mutually exclusive events, it means that A intercept B, well, it means there is no intersection between the two outcomes. So it's a null set for A intercept B, and that means that the probability of A intercept B occurring is equal to 0. There's no chance that it's going to occur. If you were to draw a diagram of a Venn diagram of two mutually exclusive events, it would look like this. There would be no crossover, no intersection point where they cross over. They're two completely mutually exclusive events. Independent events are if the occurrence of one event has no effect on the occurrence of the other event. So this time, in the first example, we were talking about one flip of a coin and the two different outcomes, or one roll of a dice, you could say, and the 6 different outcomes. Now we're talking about two or more events happening. And so it could be two rolls of the die or two coin flips. So the example I've got here is if you roll a die twice, you score a 4 on the first roll, the chance of getting another 4 on the second roll is exactly the same on the second roll. It's not influenced by the outcome of the first roll. So if you have that happening, we say those two events are independent. Two rolls of the dice are independent of each other. I've got this in green, really important. If two events are independent, then they can't be mutually exclusive as well. And the same applies if two events are mutually exclusive, they can't be independent. You can only have one or the other. Moving on with the independent events, if we do have A and B are independent events, then the probability of A happening, given that we already know B's happened, we don't really care that B's already happened. It doesn't really impact on what's going to happen with A. So the probability of A given B for independent events is just going to be the same as the probability of A happening. If we look further and say the probability of B can't be equal to 0, so it's actually got a chance of happening, then we can use our conditional probability rule from the previous video. Probability of A given B equals probability of A intercept B over probability of B. We've now got two things that are equal to A given B. So we can make these two things equal to each other. Probability of A equals probability of A intercept B over probability of B. And multiplying the B so it's on this side, we end up with probability of A intercept B equals probability of A times the probability of B. this is a great rule to put in your summary book. I'm going to put a red box around it. And this is the rule for independence. So I'll just put on the side here, only works for independent events. You can also use this rule to prove two events are independent. If the probability of A times the probability of B is the probability of A intercept B, then you can say those two events are independent. Our first example here says, say we roll a die twice and define the following events. Event A is the first roll is a 5. Event B is the second roll is a 5. Event C is the sum of the numbers showing is at least 10. And the questions are A and B independent? And are A and C independent? So, first thing we need to think about, A and B. Now, what I'd recommend doing first of all is thinking about this from a realistic real life point of view. If you're rolling a dice once, then you're rolling it again, is the outcome of the second roll going to be dependent on what happens in the first roll? And hopefully you're going to say no, the outcome is always going to be the same. At this point, if you'd like to pause the video and have a go at completing this solution yourself, you're welcome to do that. Otherwise, you can continue listening to hear the solution. So what I've written for the first part of my solution is, since A and B are physically independent, we know we're doing two separate rolls of the dice, then they're also going to be mathematically independent. So we know in our head they are independent, but we need to make sure we can prove it. So we can check it by using the rule for independent events. That's this rule up here in the red box. And for that rule to work, we're going to need to use probability of A happening. A was probability of rolling a 5 on the first roll, so that's just 1 in 6. Probability of B happening is the probability of rolling a 5 on the second roll, same thing, 1 on 6. And the other, so we've got probability of A, probability of B. The other thing we need is the probability of A intercept B. To find that, we need to work out, oh actually I'll get rid of this probability. First of all, we need to work out what the intersection is between A and B happening. So if the first roll is a 5, the second roll is a 5, all the different outcomes we could get that look like that. So just writing out our sample space, there's only really one outcome we could get, which is a 5 and a 5. So because there's only one, you need to think about how many different outcomes there would be if you rolled a dice twice. And hopefully you got to 36, 6 times 6. So the probability of, not union, intersect, A intersect B, probability of this happening is 1 chance out of 36. Now we can write out our independent events formula. A intercept B equals probability of A times the probability of B. And we get 1/6 times 1/6, which equals 1/36. And we know A intercept B here is 1/36. So we get 1/36 equals 1/36, correct. Therefore, A and B are independent. If it wasn't equal, you would put a slash through and say is not equal to, and then put A and B are not independent. Question B was about A and C. Are A and C independent? And remember, C is the sum of numbers showing to be at least 10. So we need to think about all the outcomes that could possibly happen for C. And I've written them out for you here. You could get a 4 on the first roll and a 6, a 5 and a 5, a 5 and a 6, 6 and a 4. They're all listed there and they're all in the squiggly brackets. This is a convention when you're writing out 2 rolls of a dice. You put the 2 rolls in normal brackets, separated by a comma, and then put a comma in between each outcome as well. And the whole thing goes in squiggly brackets. The probability of C occurring is this many, 1, 2, 3, 4, 5, 6 outcomes out of 36 altogether, which is 1/6. The probability of A intercept C is where how many of these are also in A. So A was roll a 5 on the first roll is a 5. So how many of these have a 5 in the first number? This one? This one? That's it. So again, I'm going to, just to make it clear, A intercept C is 5, 5 and 5, 6. So we've got 2 outcomes. The probability of A intercept C is, excuse me, 2 out of 36, which is 1/18. Now we can write out our independent events formula. This time it's probability A intercept C, probability of A times probability of C. A intercept C here, 1/18. Probability of A back up here was 1/6. Probability of C here is 1/6. And we get 1/36 on this side and 1/18 on here. 1/18 and 1/36 are not equal to each other. Therefore, A and C are not independent. And if you think about that going back, C was, I'll go back to the question. Question B I'm talking about. Event C is the sum of the numbers showing is at least 10. So have a think about it. If you rolled a 1 for your first roll, would that impact on whether you could possibly get a 10 for your second roll? And it will. So what you roll on the first roll does impact what you get on the second roll. So they're not independent. They are dependent on each other or conditional. Thanks for watching the video.